So in this video, we will learn how do we evaluate a double integral when the limits are constant. Okay, so how it is defined? Like you have a function of two variables x and y, which is continuous throughout the region xy, where x lies between a to b and y lies between c to d. So if this is your x-axis, this is y-axis, say this is, so your region will be, say if this is your x equal to a and x equal to b, y equal to c and y equal to d. So on over this region, this is the region R. So if the function is defined over this rectangular region R and it's continuous, then we define the double integral. This is how we write the notation. Double integral over the region R. This is your R of fxy dxy as, so now you know the limits. X varies from a to b, y varies from c to d. So you can write it here like x goes from a to b, y is from c to d. Always smaller number to bigger number. Okay. So you can write this integral as integral a b c d. Now see, these are the limits for x, a, b, and these are the limits for CD. So you write first dy and then dx, because see, if you from the function, if you move on the either side, so first position is for y, second is for x. So first you integrate with y, then with x. Or you can also rewrite it as, see, y equal to c to d, integral from x from a to b. Now see, first inside you have the limit of x. So you should write here dx and then dy. Okay. So from the function, if you move outward, it is 1, 2. First is x. So first should be integration with x, second with. We'll understand this again when we do example in this way. Okay. But let's start how to solve a double integral. So whenever we are solving a double integral on a over a rectangular region, we always solve it as an iterated integral. So what we are going to do, we are going to solve these two integrals one by one. So first thing you will do is you will solve this integral, which is in this bracket. Okay. So what you can see is dy dx dy. So let me write down this integral. 0 to 3 to x minus 4y cube dy. So here I am integrating with respect to which variable? Y, because of dy. So when you are integrating with respect to y, this becomes the limits of y. Okay. Constant is x. So integrate it now as we did in the previous video. So there is no y in the first term. In the second term, you have a function of y. So let's integrate it. So this gives you 2x. Since there is no y, we multiply by y minus 4. Integration of y cube is y power 4 over 4. Okay, since this is a definite integral, we will not write plus c. And then we just substitute the limits from 0 to 3. Here we can cancel 4 with 4. So what you have to do in the next step, replace y first time by 3 and then by 0. So this gives you 2x times 3 minus 3 to the power 4 minus 2x into 0 minus 0 power 4 over 0 power 4. So these are the limits when y is 3 and this when y is 0. This becomes 0, this becomes 0. So you left with only first term that gives you 3 times 2, 6x minus 3 to the power 4. That is 81. Okay. So see, you finished integration with respect to y, and this you have no y term. It means you are going correct. Now, in this integral, what is left? We left with only the outer integral and dx. So let's write this. Minus 5 to 4. And this bracket, the value of this bracket is this. This is what we just saw. If I name this bracket as I was solving I. And this is the value of I. So see, 6x minus 81 dx. Now it becomes a normal definite integral. Here you are integrating with respect to x. Okay, so just integrate it. 6 integration of x square over 2 minus 81x. The limits for x is from minus 5 to 4. So here you can cancel this to make it 3. And after that, what you left with? Just the limit substitution. 3 into 4 power 2 minus 81 times 4 minus 3 minus 5 power 2 minus 81 into minus 5. Okay, this is at x equal to 4 and this is at x equal to minus 5. Okay, and then you can do the simplification by using calculator. So you'll get a number. Okay, let's look at another example. Suppose you have this. Evaluate the integral 1 to 2, 0 to 1, x plus y power minus 2 dx dy. So you see that first you are integrating with respect to x, then with y. So these are the limits for x and these are the limits for y. So x is varying from 0 to 1, y is varying from 1 to 2. So doing in the same way, we first integrate this rectangle with respect to dx. So let's write it down here. Integral 0 to 1 x plus y to the power minus 2 dx. Now since the whole term is power minus 2, so what you will be doing? You will be using this rule. Ax plus b power n dx. This gives you ax plus b power n plus 1 over n plus 1 multiplied with a, which is the coefficient of x, the variable with which you are integrating. Okay, so let's check first. Here we are integrating with respect to which variable? Yes, because of dx, we are integrating with respect to x and constant is y. So when we integrate this, what we will get? X plus y to the power minus 2 plus 1 over minus 2 plus 1. We are integrating with respect to y. The coefficient of y is 1. So it's like multiplying this by 1 or not writing 1. It's same. Okay. And the limits for x from 0 to 1. These are the limits for x. Okay. So what this gives you? X plus y to the power minus 1 over minus 1. Where x varies from 0 to 1. So this gives us, this is negative. So you can write it as 1 over, because it will go in the denominator. X is 1. So you are just changing this x. 1 time by 1 and then by 0. So 1 plus y plus 1 over 0 plus 1. Power minus 1 become 1. So we left with minus 1 over 1 plus y plus 1 over y. Okay. Now let's evaluate the outer integral. 1 to 2. In place of this bracket, which value is 1, is this. So 1 minus 1 over 1 plus y, that's 1 over y dy. So it is now a function of one variable only. It becomes definite integral. So how you integrate? Yes, this is minus ln of mod of 1 plus y plus ln of y. And the limits for y is from 1 to 2. So in the next step, you will be just replacing y by 2 and 1. That gives you minus ln of 3 plus ln of 2 minus ln of 1 plus ln of, sorry, not 1, it should be 2 here, ln of, because when you replace y by 1, 1 plus 1, that is 2, and ln of 1. Okay, so ln of 1 is 0. This minus minus become plus. So you get your answer as minus ln of 3 plus ln of 2 and again ln of 2. So you get 2 times ln of 2. Okay. Let's quickly take one more example. So doing in the same way, what we have to do is evaluate this integral. So integral minus 3 to 2 y square x dy. So here we have to integrate with respect to y. Constant is x. Now as we are integrating with respect to y, these are limits for y. And remember, this whole is one term. So you will be just integrating y power 2. Keep x same. So this gives you y power 3 over 3 x. And the limits for y is from minus 3 to 2. Replace it, 2 power 3 over 3 times x, because we are just changing y by 2 and minus 3. Minus 3 power 3 over 3 times x. So what we did? Changed. Okay. This is let y equal to 2, let y equal to minus 3. When you simplify, what you get? 8 over 3 x minus 3 times, so become plus 3 3s are 9, 9 to 27 over 3, so you get 9x. Now both are terms with x, you can further add them. So you will get 35 over 3x. You can, if you want, you can write in the decimal as well. Now see carefully. Here we are integrating with respect to y. So the term that you get, it doesn't have y. So it means yes, you are going correct. Okay. So let's say this was I, like first part. The result is now this. So using this here in the given integral, we have 0 to 1. In place of this, we have 35 over 3x dx. So here you should have only x, no y, only x. Okay, so just integrate. It is 35 over 3 x square over 2 from 0 to 1. These are the limits for x. So you can say 35 over 6 x square, limits from 0 to 1, which gives you 35 over 6, 1 square minus 0 square. So the final answer will be 35 over 6.